All right, start on 9.5. 9.5, we're getting our other two trig ratios. So we're getting what's called sine and cosine here. And so we talked about tangent already yesterday. Tangent was opposite leg over adjacent leg. And we didn't touch the hypotenuse. Well, now we're going to bring the hypotenuse into it. Okay, so we're looking for sine. Sine is going to be the opposite leg over the hypotenuse. So sine, if we abbreviate it, sine is going to be opposite over hypotenuse. Okay, opposite over hypotenuse. So if we're talking in terms of A, and remember it changes depending on what angle we're dealing with. So angle A, we would go opposite and hypotenuse. Okay, so opposite over hypotenuse. So we have that 3, 4, 5 triangle like we talked about, and we're talking about the sine of A. So the sine of A would end up being 3 over 5. Okay, opposite over hypotenuse for that. Okay, so that sine is opposite over hypotenuse. If we look at cosine, cosine is adjacent over hypotenuse. So our cosine here, our cosine is equal to adjacent over hypotenuse. So it's still important that we know the difference between that opposite and adjacent because it's going to give us different values, okay, depending on sine and cosine. So for this case, cosine of A would be adjacent over hypotenuse. So 4 over 5. So as we can see, they are different here, right? Sine of A, cosine of A are going to give us those different ratios because we're using different sides on top. The bottom is going to be the same because the bottom is the hypotenuse for both. So you got 3 over 5, you got 4 over 5. It all depends on which leg we're using. Okay. And again, just like we talked about with tangent, it really matters what angle you're using. Because if we're talking sine of A, yes, it's 3 over 5. But if I'm talking sine of B instead, well, sine of B, in terms of B, 4 is now the opposite, right? 4 is across from B, and then 5 is still the hypotenuse. So sine of B is going to be 4 over 5, right? Cosine of B, now according to B, this is the adjacent side, right? So cosine of B, that would be 3 over 5. So you really got to pay attention. You got to be careful because these are all very similar to each other, right? These are all very similar. If I take out the abbreviated versions here, we can see they're very similar, right? Sine of A is the same thing as cosine of B. So that's something to keep in mind as well. Because according to A, this is the opposite side, but according to B, this is the adjacent side. So depending on sine versus cosine and which angle, you could be looking at the same angle or the same ratio, but it depends on what angle and then what sides we're looking at, whether it's sine or cosine. Okay, so that's our general idea for today: is sine and cosine. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and that's going to be the trick, is to keep those straight. Okay, in a little bit, I'll show you how maybe we can help to keep those straight so we know which one we're supposed to use when. Okay? So let's take a look at some examples of problems that we're going to see here. So we're going to see something similar to what I just had on there. Right? So if we look at sine S, sine R, cosine S, cosine R, we should be able to come up with those fractions. And they want the fractions and then the decimal as well, just like we did yesterday, where we found that fraction, use the calculator, divide it, get that decimal equivalent. So if we're looking at sine S, and you can pause it and try these out on your own if you'd like, and see if you got them, and then just fast forward a little bit until I've got the answers up there. That works too. But we got sine S is going to be opposite over hypotenuse. So according to S, the opposite is 63, and then the hypotenuse is 65. So sine of S is going to be 63 over 65. And then whatever that gives me when I divide it, probably a 0.9 something. Sine of R, okay, now according to R, 16 is the opposite, and 65 still hypotenuse. So sine of r would be 16 over 65. Cosine of s, okay, according to s, cosine the adjacent is 16 over 65. Remember, sine of one is equal to the cosine of the other, right? Sine of one is equal to cosine of the other, which means cosine of cosine of r, okay, cosine of r here is going to give me 63 over 65, because the sine of one acute angle is equal to the cosine of the other acute angle, right? And we can see that there, cosine of r, adjacent, hypotenuse. Good, hopefully we got that. So that idea of the sine of one is equal to the cosine of the other, we can use that idea to rewrite these things using sine versus cosine. So for example, what I mean is if I have the sine of 25 degrees, we can rewrite that in terms of cosine, because remember, the sine of one acute angle is going to be equal to the cosine of the other acute angle. So you got to think, what would that other acute angle be if I've got a 25 degree angle? Well, that's just triangle sum theorem. We're subtracting it from 90. That would give me a 65 degree angle for the other. So if I've got 25 here, I'm going to have 65 here. So the sine of 25 is going to be equal to the cosine of 65. Okay, these two are going to be equal to each other. If I had the cosine of 20, that would be equal to the sine of 70. Those would be equal to each other. And you could type those into the calculator and get them and make sure that they're the same, but they're going to be the same. Right? And they're going to have that in the book for you here. Right? If we want to write sine 56 in terms of cosine, right? You see it here, 90 minus that 56 gives us that 34, so it'd be cosine of 34. Okay, that's exactly what I was telling you. Speaking of, right, the sine, you see that I've abbreviated sine and cosine. This is not sin. I know it looks like sin, it's spelled like sin. That's an abbreviation for sine. Okay, so we're talking sine 25. And COS is not cos, okay? It's cosine 65. I know I abbreviated tangent, TAN, and I call that tan, okay? But I'm still gonna call this sine 25 cosine 65. Okay? Just, it's a pet peeve when I hear people call that sin. It's not sin, it's sine. Okay. All right, good deal. So just like tangent, we can type those into the calculator. And the calculator is going to give us that ratio that is guaranteed to be true for that type of angle, right? If I've got a 30, 60, 90, and let's say I want the sine of 30, no matter how big, how small that triangle is, if this is a 30 degree angle, the relationship between these two sides is always going to be the same. And we know that from our, or not these two sides, so that would be tangent. But sine of 30 would be these two, would be the opposite and the hypotenuse. And we know that's going to be the same because it always follows that general form. So in this case, sine of 30 is always going to be x over 2x. This shorter leg is always going to be half of the longer side. So that relationship, sine of 30, is going to be 1/2. It's going to be 1/2 as big. Okay, and if you type that right into the calculator, you type sine 30 into the calculator, we're going to get 0.5. It's going to give you 1/2. Okay? So we're going to use, just like we did with the tangent, we're going to use that fact to be able to solve for certain side lengths. Okay, so let's look at that now. So now, because we've got all three trig ratios here, and specifically we've got the sine and the tangent today, we can solve something like this, where they give us one angle, they give us one side, we solve for the other two. You just got to keep straight which one you're going to use for x, which one you're going to use for y, right? Sine, cosine, tangent, what are we going to use? So we're going to solve for x first here. So the trick is to pay attention to what angle you have. And according to that angle, are we dealing with opposite? Are we dealing with adjacent, hypotenuse? What are we dealing with? So they gave us a 26-degree angle. So I'm going to deal with that angle. We could subtract it from 90 and get this angle. I don't mess with that. I'm going to use the angle that they actually gave us. Okay. So I'm going to deal with this 26-degree angle. If I'm solving for x, that is the opposite side, right? That's a cross. That's the opposite side. So if I'm solving for the opposite side and they gave me the hypotenuse, that means I'm using the opposite and hypotenuse. That's going to be sine. Because remember, sine is opposite over hypotenuse. So I'm going to use sine. So I'm going to say sine of 26 is equal to the opposite side over the hypotenuse. So I get that equation. We talked yesterday. Just multiply both sides by 14. That would give us 14 sine 26 is equal to x. We can round to the nearest 10 and we'll get it. All right, now, if I want to find y, okay, I don't need to find the other angle or anything like that. Now, the y, that's the adjacent side. That's the one that's next to the 26 degrees. So adjacent, I'm using cosine, because that's adjacent over hypotenuse. So I'm going to go cosine of 26 is equal to y over 14. Right, now I've got adjacent over hypotenuse. Hypotenuse is always on the bottom today. Hypotenuse is always on the bottom today. I multiply by that 14 cosine 26. We multiply it out, use the calculator. That's going to give us that x, that y value that we want. We're going to end up with 6.1 for x. We're going to end up with 12.6 for y. Okay, so we're going to see that. Now, one type that we didn't just see there, and if you need to go back and watch that again and see, all right, why did I use this side? Why did I use sine? Why did I use cosine, right? Go back, watch it again, figure it out. The one side, the one type that they didn't really show us there that we can still do is when we're trying to solve for that hypotenuse. All right, so let's say this is a 20-degree angle. We're looking for the hypotenuse. They need to give us one of these sides. Let's say they give us this side is 15. Okay. We need to figure out what we're going to use. Sine, cosine, tangent. What are we going to use there? Well, according to that 20-degree angle, I've got the adjacent side. Okay, that's the adjacent leg. And we're looking for the hypotenuse. So adjacent, hypotenuse, that's going to be cosine. Right? Cosine is adjacent and hypotenuse. So this would be cosine of 20 is equal to that adjacent over the hypotenuse. We get cosine 20, 15 over x. And remember what we said yesterday, if we're solving for x, we are simply switching switching with what's on the other side of the equal sign. So x is equal to 15 over cosine 20. We multiply that out, or sorry, divide that out using the calculator, we're going to get our answer. Okay. All right. So we know how to find all the sides using sine and cosine. Let's talk about where sine, cosine, tangent comes from. Okay, the history of it, if you will. There was an old Indian chief that came up with this. Okay, a long time. We're talking thousands of years ago. Right? Name was Chief Sokotoa. Okay, Sokotoa, a little history lesson. Chief Sokotoa, and amazingly enough, he came up with sine, cosine, tangent, realized that these sides were all the same. The ratios were going to be the same no matter what. And even better than that, his name helps us remember what sine, cosine, tangent are. They help us remember, as long as we can spell Sokotoa correctly. So usually if we're in class together, right, I don't have a class in front of me right now, but usually if we're in class together, I'd have you figure out how his name is going to help us. And maybe you already see it. I'll show you. So if we split it up here, this is saying sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Okay, so as long as we know how to spell Sokotoa, and we remember what each letter stands for, this reminds us. Guys, when I do trig problems, I still think Sokotoa. I promise you that older brothers and sisters, friends, probably even parents are going to remember Sokotoa. If you tell them you're doing trig, they're going to say Sokotoa. They're going to remember that. Okay. I don't think there was actually an Indian chief named Sokotoa. Okay, that's just a story that everybody knows. I was told that story back in the day to help us remember that that way of remembering sine, cosine, tangent. Okay, so if you can remember that, again, that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And like we did yesterday, tangent is equal to opposite over adjacent. So SOHCAHTOA is really going to help us remember what we're going to use where. So if we have an angle, we know we have the opposite side and the adjacent side. Well, opposite and adjacent, we're using tangent. Right? If we know we have the hypotenuse and we have the opposite, well, opposite hypotenuse, we're using sine. Okay, that helps us to figure out which one we're going to use where. All right. That being said, a couple last things here that we're going to talk about. Again, anytime they have us finding sine, cosine, tangent of a 30-degree angle, a 60-degree angle, a 45-degree angle, we're going to use the general form of that shortcut. Okay, we're not actually going to type it into the calculator. You'll notice here, find the cosine, sine and cosine of 30-degree angle. They don't tell us to round at all. And if they don't tell us to round, that means we need exact answers. We need simplest radical form. So sine and cosine of a 30-degree angle. Let's look at this one real quick. We got 30 degrees here, 60 here. Our general form, that's x 2x and x root 3. We already talked a little bit about the sine. Let's look at why. Sine of 30 here is going to be opposite over hypotenuse. Opposite over hypotenuse is x over 2x. Those x's are going to cancel. That means there's got to be a 1 there. That leaves us with sine of 30 is equal to 1/2 or 1/5. Cosine now, cosine of 30. Cosine of 30 is going to be the adjacent. So x root 3 over the hypotenuse, which is 2x. Those x's again are going to cancel. The cosine of 30 now is going to be root 3 over 2. Okay, we can leave it like that because there's not a square root in the denominator. I can leave it just like that, and that's my answer for that. The only other thing that we got to talk about, we talked in the last section about angle of elevation. Well, now we got to talk about angle of depression. Okay, angle of depression here. An angle of depression is messed up more than the angle of elevation. But angle of depression is always from the horizontal down. Okay, angle of depression. Depression means down, right? So I've got my horizontal, I am looking down. This right here is the angle of depression. Okay, a lot of times people think that this is the angle of depression here. It's from the horizontal down. So if we're looking from, let's say, I know in the old book there used to be this we were on a tower and we were seeing a fire, like it was a fire tower or whatever. We saw this fire down here, a very accurate drawing, as you can tell. And they said, all right, the tower is 100 feet tall, and the angle of depression to the fire is 30 degrees. No, let's not use 30. Let's say 25 degrees. Okay, so the angle of depression to the fire is 25 degrees. We want to know how far away is the fire. Well, if the angle of depression is 25 degrees, a lot of times people are going to try to put that 25 here. 25 doesn't go here. Okay, the angle of depression, like we said, is the horizontal down. So here, this angle would be that 25 degrees. That's the angle of depression. Okay, it's from the horizontal down. So that's the angle of depression. You'll notice that angle is not in this triangle that I'm trying to solve for. So I can't use that 25 here. Okay, the common mistake, again, is to put that 25 here. A couple different ways we can do this to make it so that we can solve the triangle. We can either use AIA, right? Because if it's horizontal, the ground's horizontal, these are parallel. AIA tells me that this has to be 25 as well, and then solve there using tangent, opposite over adjacent. Or we know that this has to add up to 90. So I can do 90 minus 25, make that 65.
Jolene, please come to the main office. Jolene, please come to the main office.
pronounce stuff after school. So we could make that 65 and then use opposite over adjacent, use tangent the other way using that angle. We just have to find that correct angle, use that correct angle. Let me show you just one example of it and we'll be good. This is a skiing one for all you skiers out there. We're skiing on a mountain with an altitude of 1200, angle of depression is 21. Find the distance you ski down the mountain to the nearest foot. So if we do that, this is going to be very similar to what I just showed you, right? The altitude is 1200. This is another way that you could solve it. Instead of putting the 1200 here, you can form the triangle over here, and this height is going to be the same as this height. So we can do that. But if you're going to call this 1200 feet, and we want to know x, we want to know that hypotenuse. Again, you can either call this 21 because of AIA, or you can do 90 minus 21 to get here, which would be 69 degrees, right? Or you can think of this as 21. Depending on which one you use, you're going to set it up differently to solve for x. If you're using the 21, then 1200 feet, that's the opposite. Opposite over hypotenuse. So that's going to be sine of 21 is equal to 1200 over x. And we can solve that by switching the sine 21 and the x. Or if I'm going to use the 69 degrees, that's the adjacent. So that would be cosine of 69. So cosine 69 is equal to the adjacent over the hypotenuse. So you see the fraction is the same, right? These are different, but remember what we said earlier in the lesson. The sine of one is equal to the cosine of the other, which means that it's okay that these are different, but these are the same. You could use either one of these to solve for x. We solved that out by switching the x with the other side of the equal sign. We're going to end up, you're skiing down 3,348.5 feet. So about 3,349 feet down that mountain. Okay, that's what we're looking at. So big idea, SOHCAHTOA, make sure you know sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Make sure we know that and can apply it. The next section takes us into how to find the angles, but we're not there yet. We're simply finding the side lengths right now, and then we'll move forward after this. Okay, there you go.